Hey, mathematicians, and get ready as today we explore how to find common units or number of units and use that to help us compare two different fractions. Let's get into it with our I will statements.
Remember, your I will statements are your goals for this lesson. They are what we are trying to work on and learn more about throughout our time together today. As we continue on in our lesson, make sure you have your mind focused on these three things and showing them to your teacher. I will read the I will statement first, and then we will read it again a second time together. Make sure you're reading it nice and loudly so I can hear you, but no shouting necessary.
Listen as I read the first one. I will write a number sentence comparing two fractions. Read that one with me. I will write a number sentence comparing two fractions. The next one, listen to me first. I will identify fractions on a number line. Read that one with me. I will identify fractions on a number line. And our last one. I will draw fractions in a picture. Read that one with me. I will draw fractions in a picture. Nice job, mathematicians. Let's get into it with our warm-up. For this first homework activity, we're going to practice constructing a number line using fractions. Let's start off by drawing a number line on our whiteboards. For your number line, on the left and right side, put little dashes for our numbers. On our number line, now that it is partitioned into two equal parts, we are going to split it down the middle. So we have two separate parts. And on the left side, on our endpoint, we're going to have a 1. And on the right side, on our endpoint, we're going to have a 2. So this is where our number line starts and ends. Let's plot the middle point here, since it's right between 1 and 2, would be 1 and a half. On our number lines, let's plot 6/5. Remember in our old lessons how we practiced plotting fractions on our number line. Right now, our number line is just partitioned into equal parts. 6/5, we know, is equal to 1 and 1/5. Is 1 and 1/5 bigger? No. We could also partition this by thinking if our number line continued and was split into 5 equal parts, we would come up to the 1 and only get 1 bounce over. This is where that 1/5 would be, that 1 and 1/5. So 6/5 is less than 1 and 1/2. I'm going to erase this and the little dashes I added onto my whiteboard, and we're going to do another one together. Let's say we were going to compare 1 and 1/2. We're going to compare that to 17/10. So if we were thinking about 17/10, if we split our number line up into tenths, right now it's just partitioned into halves. Let's split each of these sides up into fifths. So I'm going to add 1, 2, I'm going to erase that again. I'm going to add 4 lines. 1, 2, 3, 4. 1, 2, 3, 4, 5. That way I have 5 sections on this side of my board. And 1, 2, 3, 4 on this side. That way this is now split up into tenths. To get from 0 to 1, so to get to our endpoint here, would be 10 out of 10. We have 17 out of 10, so we need to count up 7 more. 1, 2, 3, 4, 5, 6, 7. When I plot this on my number line, 17/10 comes out to be more than 1 and 1/2. To show that, I would draw my alligator eating the 17/10. I'm going to show you two more fractions that I want you guys to compare using your number lines. Let's erase our whiteboards and redraw our original number line now. The next two fractions I want you to try comparing using your number line are the following. 17/10, compare this to 6/5. The other one I want you to try using your number line, compare 19/12 to 7/4. Draw your number line to show how you compared these two fractions and then fill in the missing symbol for each of these spaces. Come back when you're ready for the answers. This would be the following answers for the problems I gave you in the warm-up. 17/10 is greater than 6/5, and 19/12 is less than 7/4. If you got those past yourselves on the back, mathematicians, you can clear your whiteboards and stretch out your bodies as we get ready to start our lesson for today. All you'll need is your whiteboards and your markers. If we were trying to think what is greater, 1 apple in our kitchen or 3 apples in our kitchen, what would be the greater amount? Did you say 3 apples would be the greater amount? 3 apples would be the greater amount. Let's write that on our whiteboards using our greater than sign facing the 3 apples. If we were thinking about fractions, if I said you could have 1/4 of my apple, or if I said you could have 3/4 of my apple, which of these would be bigger? Well, if I thought about this like it was on a number line or even as a picture, I know that 3/4 is the greater amount. To have 3 out of 4 pieces is to have more than having 1 out of 4 pieces. If we look at these two statements, 1/4 and 3/4, the units are the same in each of them. One is apples and the other is fourths. We can compare the numbers of the fourths like we compare the numbers of the apples themselves. So it's an easy way for us to compare when the units are the same. Let's think about this. Which is greater, 1/4 or 1/5? Now this is different now because I changed the units. 1/4 is bigger than 1/5. There's multiple ways we can know this. We can draw ourselves a strip diagram. We can partition our whole into fourths on one strip diagram and fifths into the other. Since there are more fifths than fourths, so each fourth piece is going to be bigger than a fifth piece. We can tell that using our strip diagram. You might also know that 1/5 is less than 1/4 because fifths are smaller than fourths. You might know that without actually drawing your strip diagram, but it may help. Let's think about this. Which is greater? 2/4 or 2/6? Which one is greater out of these two? Well, if we were to look at these 2/4, think about if I had my strip diagram and I partitioned it into fourths, took 2 of them, compared to if I have my same size or my strip diagram over here and I have 6 pieces and I've taken 2 of, I can see that I've taken more from this strip diagram than I did from this strip diagram. When I look at this comparison and our original comparison of 1/4 being greater than 1/5, we use similar mechanisms to compare these two fractions. If I were to compare these two statements, I know that fourths are greater than fifths and sixths. I can tell that because the fourths are taking up more on this side. In each of our comparisons, I also can notice that the numerators are the same, but the denominators are different. Let's break this down a little bit more, finding some more patterns while comparing our fractions. Which do you think would be greater, 2 inches or 2 feet? Well, 2 feet, because I know 2 feet is a lot bigger than 2 inches. I can use that on a ruler to help me find that. In the same way that 2/4 is greater than 2/6, because fourths are greater than 6. 2/4 is greater than 2/6, because we know that fourths are greater than 6. They're bigger pieces of that slice of our strip diagram, whereas if we're to cut it into 6, they're smaller pieces. When the numerator is the same, we can look at the denominator to reason about which fraction is greater. The greater the denominator, so in this case, if our denominator ended with a 6, the smaller the fractional unit's going to be. So if I were to draw 2/6, here's my 2/6, and if I were to draw 2/4, I can say that my 2/6, each of these slices is smaller than my fourth slice. Because of that, we're able just to think about the individual pieces. So when we look at the denominator, the greater the denominator, the smaller the fractional unit. You're going to continue to compare some fractions looking at related numerators as well. Use your strip diagrams and continue to find patterns while finding and comparing fractions. Good luck, mathematicians, and I'll see you guys soon.